Okay, in problem 35, we have cable customers, and they've called more than twice, so they've called frequently. And of those, 12 are no longer with the company. You can either call that a risk, or it's really just the probability of something occurring, or you can call it the probability of X, where X is that they're no longer with the company. So for those who have called support, the probability is going to be 12 out of 100. Those are people who called or complained or whatever you want to call it. They call technical support. And then there are those who have not called. So of those who haven't called technical support more than twice in the past 6 months, 4 out of 100 are not there. So that's 0.12, and that's 0.4. And so if we're looking for the relative risk, that's just the 0.12 divided by 0.4, which is 3. And so that'll be option B. And the next one, now we have someone who's thinking about adding a realistic job preview. And so they have a random sample of 200. This is in the traditional form. They have a sample size of 200. And of those, 122 are still with the company 3 years later. And so, and that are no longer there. Maybe I should have used that instead, because we're looking at no longer there. Turnover, X is equal to 78. If 128 are still here, 78 left. So in another sample of 200, and these are ones that have completed the RJP, of those, 164 are still with the company. But we're looking at, I read down to the question here, it's that an employee is no longer here. So X is 36 there. So the proportion here is 78 out of 200. It's equal to 0.39. And you can call that a probability, or you can call it the risk. And for this one, it'll be 36 out of 200, or 0.18. So the risk difference will just be 0.39 minus 0.18 is 0.21. Now that's the risk difference. Remember, if it was risk ratio, we would have been dividing. We would have had the 0.39 divided by the 0.18. But difference is just what it says, difference. Okay, so we have a toy manufacturer wants to test 3 different types of hinges, and boys and girls tend to play differently. How should you study this? Well, you should use a blocked design experiment blocking on gender. What that just says is, since they play differently, if we're going to have, let's say, 60 children, and let's say that 30 of them are boys and 30 of them are girls, for hinge A, you want 10 boys. For hinge B, 10 boys. For hinge C, 10 boys. And then 10 girls with each as well. So you don't confound the results of your study by whether it was boys or girls that were playing with the toys. Which of the following is true about a double-blind assignment? That's when neither subjects nor evaluators know which treatment group the subjects are in. So the people who are participating as subjects in this experiment don't know. That would be a single blind. But when the people who are interacting with them, the evaluators, also don't know, then that is a double-blind experiment. And we have a firm that's hired to test new formulations. First, they divide into 5 age groups and then select from each group. That is stratified sampling. They have the different groups that they think are homogeneous within, but then make sure that you get randomly select people from each of those stratifications. I think I'll stop on that one.